is Elyès from Scaleway, a French cloud service provider. I'm glad today to share with you our hardware management return of experience at Scaleway. The content of the presentation is mainly, it consists of three main parts. The first part is about an overview of the hardware platform management ecosystem. Then I will present some use cases of hardware management at Scaleway. And finally, the presentation will contain some challenges and some issues we've noticed when using platform management interfaces. So here is the schematic about hardware platform management. It's BMC centric, and the first interface represented is the out-of-band interface, which is obviously familiar to many of you, as it's the main user interface when needing to interact with BMC. It's an out-of-the-box interface, so a remote hardware management system is required, and it also requires using generic clients like Redfish or IPMI, or vendor-specific OEM clients. Sorry, I've lost the presentation. Oops. Okay. The bottom interface is host interface, also called in-band interface, which is also a user interface when hardware management commands are executed from the operating system. And it also relies on Redfish IPMI clients and OEM clients. And it's an interface that we use intensively at Scaleway. To complete the scope, I've added two other interfaces belonging to the scope of the inside-the-box interfaces. The interface at the left is the MC to MC interface, which mainly related to communications between BMC and other management controller, such as the GPU management controller, if any. And the one at the right is the interface to let the BMC communicate with managed devices or network interfaces like OCP, NICs, etc. In the context of this presentation, we'll focus on out-of-band and in-band interfaces. So what I will call hardware management in the next slides will refer to out-of-band and in-band interfaces. At Scaleway, we handle multi-vendor hardware, like servers, NICs, disks, etc. And this leads to multiple interfaces, data sources, standards. As an example for standards, there are IPMI, Redfish, FRU specifications, etc. This also leads to the usage of several tools and dependencies, like IPMI2, RACADM, ILOREST, Super Micromanager, etc. And the consequence of this is that the integration of all these tools is complex, as well as maintenance, automation, all become complex to handle. And of course, there is a big impact on production and process, on production process efficiency, sorry. And the main idea I will explain in next slides is that we need to rely on simpler and more interoperable vendors' hardware management system. This slide is about hardware management usage across deployment process at Scaleway. Just to highlight where we are using hardware commands across the deployment process and across teams involved in this process. The first process is assembly and conformity checking, which is the process we use, in which we use hardware inventory, sanity check and conformance check, firmware update, firmware configuration, etc. Then, after being checked in terms of conformity, the hardware is discovered and prepared to be used in a data center for a specific product. And the stage, it's about discovery and pre-configuration, which means provisioning of the host operating system, fine-tune the firmware configuration with specific settings required by the teams that will operate next the hardware. It's also about DCIM system seeding. Finally, the last stage is about operating the hardware, and it also uses some hardware interaction, like monitoring, remote control, power control, firmware update if needed, and of course, it's also about troubleshooting and maintenance. So across all these stages, we use hardware management. And what is important to say is that these teams, each team has its own firmware stack, which is built on top of hardware commands and hardware interfaces. And when we need to handle heterogeneous and complicated system, of course, it will impact the development of these software stacks and their maintenance. This slide is my favorite one because I'm quite sure it will ring a bell with many of you. It's about developing, it's a high-level vision of what could resemble the development of a vendor-agnostic management system. So we have three main layers. The top one is the abstraction layer, which is a set of high-level management commands like firmware update, BIOS setting, BMC reset, etc. The middle layer is the the set of all provided tools, all tools that we rely on to implement the high-level commands, and the end layer, the bottom layer, is the target platforms coming from different vendors. So as an example, for command 1, let's assume it's BIOS reset to default command, for instance. It will rely on tool 1 provided by vendor 1, for instance, and it will interact with the OEM interface of the platform X of vendor 1. This same command for a second vendor will be based on Redfish generic tool, because vendor 2 implements Redfish interface. Why not? And let's suppose there is a second command now. For instance, disable IPv6 on BMC. This one will rely on tool number 2 of vendor 1. You can also assume that tool 1 is only in band while tool 2 is only out of band to increase complexity, which is really possible, and so on. And I call it spider web because finally it's resembled to something like this. I let you imagine what could be like a system that handles several dozens of platforms, which is the case in Scaleway, with many tools provided, mostly OEM tools. So that's the complexity issue that I will try to explain a little bit more here. The first challenge we have retained is what I call a multitude of hardware management tools. And the statement is that we have to handle many tools. For instance, and only for BMC interaction across all software platforms, we need to handle about 15 different tools for BMC interaction, including OEM and generic tools. And some tools can only be used in band, while others only work out of band. Implications of this is that we need to maintain these tools, of course, to handle operating system and tools compatibility when operating systems are updated and kernels are updated, etc. And for each new tool to be integrated, a full functional validation is required. For each time we need to integrate a new tool. I've liked what Richard said this morning. A vendor-specific tool. It's not an added value; it's an added pain. So that's the same purpose here. We are facing the same problematic. And what we recommend, if we have suggestion, if let's say it's an advice to vendors in order to improve things, is to one suggestion is to implement Redfish services, because it's a modern interface. It's better than IPMI. It's a fact. It's scalable, at least more scalable than IPMI. It uses, the other recommendation is to use unified, interoperable, and modern tools, like generic Redfish tools, and also provide tools that can be used both in band and out of band, not only in band and separately out of band. Next challenge 2, is about mismatching implementation of Redfish API. This is the challenge that motivates me the most to propose this talk. For instance, it's about what I call excessive use of OEM Redfish endpoints. The implication of it, the consequence is that when there are too many OEM schemas to be handled, at the end, we will have many Redfish APIs to interact with. So it don't reduce the complexity. It's quite the same complexity. Another issue is about partial Redfish implementation. I mean a Redfish service with missing features. So some vendors sometimes say, okay, we'll support Redfish, except BIOS reset to default and CPLD update. Okay, but in this case, we need to handle and to cover these features. So one solution is to fall back on other tools, and we don't resolve the issue of multiple tools to handle. Last issue regarding Redfish is wrong Redfish implementation or inconsistency with standards. For instance, with attributes that should be read-write, but they aren't implemented as read-only, etc. So all these inconsistencies or mismatching will don't help us to tackle the complexity problem. Our recommendations about this is to stick as much as possible to standard specification, use the MTF conformance tools listed here. There are official DMTF. We are quite sure many vendors already use this and integrate these tools in their CI/CD, but it should be really done, I mean, systematically done and not sometimes only. One answer to avoid these discrepancies is also to use OpenBMC as a reference implementation of Redfish. And that makes a transition to next challenge, because we are noticing that OpenBMC is here. There is a big community working on the project, but there is a lack of adoption. It's not fast enough. So we encourage vendors to support it, to help us to tackle the complexity problem again. And in our vision, there are two options for vendors to release OpenBMC, to provide BMC support. The first option is to build their own proprietary firmware stack to build it on OpenBMC. I mean, it could be a proprietary stack based on OpenBMC. So what's the pros of this kind of option is that it will inherit from OpenBMC with a well-known interface, full Redfish implementation. We will avoid a big number of discrepancies I've mentioned, but The drawback is there is no customization possibility in this case because it's closed source. The second option, which is the preferred one, in our opinion, is to provide an open source, OpenBMC based firmware. So we will have obviously the same advantages than the first option, but we will also have the possibility to expand and customize this solution because we have the code in-house and we can handle some bug fixes, improvements, troubleshooting, etc. One drawback, if I can call it drawback, I mean one constraint, I will say constraint, is we have to handle in this case the transfer of ownership in terms of public keys handling. We have to, there are many options in this case. We can provide our public key as a customer to the vendor, so the vendor use it when preparing the hardware. We can also flash on our own signed firmware in-house. There is also an RMA constraints when we need to return back hardware to the vendor. So we can't return it back with our own firmware, but we need to find a solution to reflash something, a firmware that the vendor can modify. As a summary, we have identified these 3 challenges. First one, to summarize, is too many tools, too many hardware management tools, and the answer for this is rely as much as possible on standards and use Redfish. Challenge 2, mismatching Redfish implementation. One answer to this is to minimize OEM vendor-specific schemas and use OpenBMC. Last challenge is need more OpenBMC-based firmware stacks with 2 possible release models. One proprietary closed source option and one open source preferred option. And then I will finish now by a kind of dream, maybe a utopia, or because honestly, discrepancies at Redfish interface level will remain. We'll still have differences between Redfish services implementation, but it should be a common goal. I mean, implementing a full Redfish, relying on a generic tool handling, even handling these differences, should be a goal shared by vendors and customers. That's all for me. If you have any question, still free.
Hi, great talk.
Thank you.
Redfish as a recommendation is brilliant, but how do you provision users on Redfish? Because at the moment in FWD we have to use IPMI to provision a Redfish user, which seems like using the old thing to use the new thing.
Yeah, a great question. I've recently, yes, I've read the DMTF specification regarding host interface.
Yeah, the ephemeral connection. That's
Yeah.
brilliant, but no one does it.
Yeah. Honestly, I have no answer. For this specific usage, I mean, in-band usage of Redfish will still need to provision users through IPMI. I know that in the first specification version, there was an option to inject users through UEFI environment that was then deprecated. I think the MTF and all the community need to think about an automated solution and a consistent solution. But personally, I have no answer to this. So currently, we still need IPMI tool to create a kind of temporary user to use at least to use Redfish for a first time. Then we can delete the user. Okay, but we need at least one user.
And second part of the question, I'm guessing on your spiderweb diagram, that's all AMD 64. If you put AA Arch 64 into the mix, it gets even worse, right?
Yeah. You mean?
Yeah, I'm guessing most of those tools don't have ARM 64 support.
The idea of having generic tools is to really be vendor agnostic, CPU agnostic. So our concern is to be able to route high-level commands to tools. So when the vendors provide the adequate tool, we will be able then to connect the high-level command to this tool, and our work should be finished there. So
it just seems crazy that you say to the vendor, "This is what we want," and they say, "No, we hear you, but here's this other thing."
Yeah,
that's so frustrating.
I'm quite sure we will need to still handle exceptions, including this kind of exceptions. What I'm only saying is that supporting full Redfish everywhere still need to be a goal for everyone. So maybe we'll never reach it, but to improve things, it still need to be a common goal.
Thank you.
Yeah, just a quick remark regarding the various tools. At least they are properly packaged, right?
One last thing about Redfish performance. It happened, I won't name names because almost every vendor is touched by that. When you hammer an endpoint, it just kills the BMC sometimes. And it's just unacceptable. You can't lose BMC connections. It's like your eyes on the production, and it happens all the time. So please fix this. So that's the first point. A second point, whenever you collect information, you have a dilemma when you gather information statistics about a given probe. And obviously hardware takes time, sometimes to talk to the microcontrollers involved, or when it has to be mux, demux, whatever. There are sometimes time-taking processes involved. So if you know that, and when you implement those, you know that, please implement some caching that you make visible, but it has to answer somehow. If you can't answer right away, it's fine. Just answer a cached value saying that it was updated last at whatever timestamp. Please do that. Anyone?
Tricky one. Sideband. So thank you, Elyès. Thank you for your talk.